morning students. Today we will learn gravitation. Students, you have studied that the force is needed to change the speed and direction of motion of the object. We observe that anything we throw in upward direction always fall towards the earth. The moon revolves around the earth. So if this is a moon and this is earth, then moon revolve around the earth. Similarly, all the planets revolve around the sun. Is there any force required for these motions? In all these cases, there must be a force. Isaac Newton could grasp that the same force is responsible for all these motions. This force is called as gravitational force. It is said that when Newton was sitting under a tree, an apple fell on him. This made Newton thinking. He thought that if Earth can attract apple, can it not attract the moon? Is the force same in both the cases? He concluded that in both the cases, same force must be acting. For this, he argued that at each point of the orbit, the moon is attracting towards the earth. Like this, at each point of the orbit, moon is attracting towards the earth instead of going in a straight line. Okay, so it must be attracted by the earth, but we do not see that moon is falling towards earth. To understand this concept, we will do one activity. So, you take one thread or a string. At one end you tie this stone, hold the other end and just whirl that thread. So what you will observe? That the stone moves in a circular orbit. This stone will move in a circular path with some speed, but the direction changes every time. At every point the direction changes. You see, the speed is constant, but there is a change in direction. So direction changes. This change in direction involves the change in velocity. And hence the acceleration. Okay, you see at every point the velocity changes, means there is an acceleration. The force that causes this acceleration and keep the body in a circular path is known as centripetal force. So write the definition of centripetal force. Right? The force that causes the acceleration and keeps the body moving along a circular path, acting towards the center is called as centripetal force. Centripetal force means center seeking force which acts towards the center seeking. That is why it is called as a centripetal force. In absence of this force, the stone will fly off along a straight line. That will be the tangent drawn at that point. Tangent is what? The perpendicular drawn at the circumference. That is a tangent. The motion of moon here here around the earth is also due to the centripetal force. And who is providing this centripetal force? The force of attraction of the earth provides the necessary centripetal force, and therefore the moon revolves around the earth. Similarly, the planets revolve around the sun. It is due to the centripetal force. Now in that case, who is providing the centripetal force? The gravitational force. The force of attraction between sun and the planets is responsible for the centripetal force. Now we will move on the topic apple and earth. So here apple is falling towards the earth. Does apple, here the earth attracts the apple. Does apple attract the earth? Whether the earth accelerates towards the apple, let us see it. Because Newton's third law says that for every action there is equal and opposite reaction. If earth is attracting apple, whether the apple is also attracting the earth, and due to that whether the earth accelerates, that we will see. So for that we will consider Newton's second law. Newton's second law. What is the mathematical statement of second law? F is equal to mv. So from this, acceleration is F by m. It shows that acceleration is inversely proportional to mass. Now you see, as compared to the mass of earth, the mass of apple is very less. So apple accelerates. But inversely, the mass of earth is very large as compared to mass of apple. So the mass is more. So acceleration of the earth is very less. Therefore, we do not observe that the earth accelerates towards the apple. Same is here. You can explain that moon attract towards the earth, but earth do not attract towards the moon because the mass of the earth is very large, and that is why earth do not accelerate towards the moon. Moon is moving around the earth due to the centripetal force. In our solar system, all the planets go around the sun. We can say that there exists a force between the sun and the planets. Newton concluded that not only the apple and the moon, but all the objects in the universe, they attract each other. This force of attraction between the objects is called as gravitational force. As this gravitational force concept is given by Newton, so it is also called as Newton's law of gravitation. Now you see, this law is applicable for small objects as well as large objects. It is applicable everywhere in the universe, so it is also called as universal law of gravitation. So, write the statement of universal law of gravitation. So, give the heading universal law of gravitation. Every object in the universe attract every other object. Every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. On next line you write, the force is along the line joining the center of two objects. The force is acting along the line joining the center of two objects. So suppose here you have two masses m1 and m2. This is m1, this is m2, separated by a certain distance r. Then according to the universal law, the force of attraction between them is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. So you combine them, so you will get F is directly proportional to m1 m2 upon r square. Proportionality constant you remove by capital G. So you will get F is equal to G m1 m2 upon r square. So this is the mathematical expression for universal law of gravitation, where G is called as gravitational constant. Let us find out its SI unit. So to find out the SI unit, we will write the formula for G. So from this formula, what is G? F r square upon m1 m2. So it is F r square upon m1 m2. So what will be its unit? Newton meter square per kg square. The value of G constant is 6.67 into 10 raised to minus 11 Newton meter square per kg square. The value is given by the scientist Cavendish. Okay, so it is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now students, if any two objects are there, the force of attraction between them is known as force of gravitation. But out of these two, if any one is earth, then that force of gravitation is called as gravity. So what is gravity? Right? Gravity is the force of attraction between earth and any object. The force of attraction between earth and any object is known as gravity. Now we will discuss the importance of universal law of gravitation. So the first application or importance is that due to this universal law, we are on the surface of earth. So write the first point, the force that binds us to the earth. Second application is that we have the atmosphere due to the gravitational force. application is that the moon revolves around the earth. Fourth application is that all planets go around the sun. Then fifth, you can write that tides are there due to the attraction between earth and moon. And sixth one is rainfall. Rainfall is also due to the gravity. So these are importance of universal law of gravitation.